Hello everyone, this is Jameson, and we're going to be going over the Art of Stat Distribution's binomial simulate number section, and we're going to be approximating the binomial distribution with the normal distribution under some specific conditions. So let's hop back into the Art of Stat Distribution's app, let's scroll down to discrete and the binomial, and let's head over to the simulate number section to kind of start talking about some things. Wait, I'm getting ahead of myself. Actually, the explore distribution section is going to make more sense in terms of talking about the binomial distribution being approximated by the normal. So the very first thing that I'd like to show you is that if the number of trials is large, then the binomial distribution will be well approximated by the normal. Well, let's define large, or what does this mean in that it would be able to actually approximate it well? Well, under the conditions that n times p is greater than or equal to 15, and n times 1 minus p is greater than or equal to 15, then it's going to actually apply this rules and it's going to be approximated well. And I'll even be able to put that graph into the normal distribution explore distribution section if we wanted to look at exactly what it looked like. So one that I know for a fact works is we're going to go with number of binomial distributions being 40, and the probability of success is 0.4, and n times p in this circumstance is going to equal 16, which is greater than 15, so it will be approximated well by the normal distribution. As you move the probability of success much lower, you'll start to see it looks less bell-shaped and doesn't look as normal as it did up here at our original 0.4. So as an example of this, if we swapped our number of Bernoulli trials to 100, and we made our probability of success 0.1, it's definitely going to break it. That is looking oddly sharp and not as normal. And that makes sense because it's not going to be well approximated due to the fact that n times p here equals only 10. So let's swap it back to what we were talking about a second ago, with our number of trials being 40 and our probability of success being 0.4. And let's keep this picture in mind of what the graph looks like. If we actually take the same mean and standard deviation from this binomial distribution and we put it into a normal graph, then we'll actually be able to see they look similar, and we can go and do that, and I'll put them side by side for you. Now let's head back over to the binomial distribution section and talk about the awesome simulate numbers section that is the last section of the binomial distribution. Let's say that you were fighting goblins for rewards in a video game, or you were giving the pigs some more gold to get some kind of reward in Minecraft. Let's use the numbers n equals 20, so let's try for a reward 20 times, and let's say our probability of success is 75%, and when we put that in, that's going to be 0.75. Let's start by trying this 100 times. So let's press the big simulate button, and it looks like a binomial graph. Let's do it again and again, and we're getting a bunch of different binomial graphs because we're simulating having done the test of 20 trials with a 0.75% chance each trial 100 times each. And they're going to always give you a different one. So let's scroll down, and let's say this first trial I got it 15 times, and then the second trial I got it 13, third 17, 15, 17, 15, and so on. This is a really neat way to test what kind of answers you'd get if you tried to run these, or if you tried to actually perform these tests. They would take an extraordinarily long time because it's impossible in terms of spending your whole life simulating this 100 times, or even if we wanted to swap this to be 1,000 times, which we could even simulate that, and you would never want to spend your time actually trying it. So that's why simulating the numbers of doing these tests makes a lot more realistic sense. So in these 3 videos, we've learned about the binomial distribution and that the distribution models the number of successes. We've also seen how to find probabilities in the normal distribution and what simulated numbers is going to look like, and how you'd save time actually performing some kind of tests simulating rather than actually doing them. It was really nice to have you for the binomial distribution, and we're going to go over some inference in some later videos. I'll see you there.